Now, yesterday we were discussing regarding traffic light controller design of a traffic light controller. For a T junction, for a T junction based upon our own specifications, based upon our own specifications. Right. Now, now here we have said that so there is conditional permission for free left. Now, if you have studied the same design of a traffic light controller for a four-way junction, from S. Ramachandran textbook, you won't see this particular condition, free left. Why is it so? The free left condition is not allowed there in that particular algorithm. Why is it so? Free left అనేది ఉండదు. Why is it so? Pavan, Sai Priya, Bhavana, Leela Krishna, ఆంజనేయులు.
సార్ అది India right system.
Right. So there the traffic is so the system of the traffic
Free
is different. Right. Free right is permitted there. So like నిమిషము right వెళ్తుంది from here, that's this. So there the free right is allowed. There it is, free right is allowed. Free right is allowed. So US model, or in foreign countries, most of the foreign countries. So driving norms అనేవి completely change ఉంటాయి. So because of that, you will be seeing it in a different way. So at the left side వెళ్ళడంది right side వెళ్ళమంటారు, right side the left side వెళ్ళాలి, and the crossings also will be different. So that's it. Now I have told you that we will be discussing multiplexer based implementation. So mux based implementation, of a traffic light controller. So this is to be discussed, and before discussing that, so we shall get into the algorithm state machines first, and after that we will discuss the mux based implementation of traffic light controller. First we will study this algorithmic state machines. Right. So a small task for every one of you. As you might have drawn the algorithms in your C language or else in your Python language. On a similar note, so you have drawn the algorithms for the combinational logic circuits also. This was also done. Combinational logic circuits also, you have drawn algorithms. Now, before discussing this topic, draw an algorithm for a simple mod 6 counter and this whenever x is equal to 1 up count, if x is equal to 0, same state, x is equal to 0 is the same state, and after final state, in final state.
Your voice cut.
Is my voice clear?
హలో
Is my voice clear? ఇప్పుడు ఓకే కదా? Dattatreya, is it okay now? Right.
Okay, sir.
Right. So whenever x is equal to 1, up count. If x is equal to 0, the same state. And in final state, output must be equal to 1. Final state or the highest state, whatever it may be. Final state or highest state. Now, can you draw a simple algorithm for a mod 6 counter? Please draw it on your notebooks. Or if you have any white pages or any rough sheets, you may draw this simple algorithm. Don't draw the state diagram again. Now, the state diagram draw cheyakandi. Algorithm. How you will be drawing an algorithm? You draw that. That is sufficient. Draw a simple algorithm for a mod 6 counter in which whenever x is equal to 1 or whenever the external control is equal to 1, up count, if it is 0, the same state, and in final state, output must be equal to 1. So draw an algorithm for this particular problem specification. If it is done, you may send a message. Waste of time. Right, 6 states. Let this be the state S naught. State S naught. Initial state. The first state. How many bits are required for representation of this particular state?
3 bits.
In this particular mod 6 counter, how many bits are required for representation of S naught? 3 bits. 0, 0, 0. Right, perfect. Now, initially it is in state S naught, and whenever it is coming across the value of x, if x is equal to 0, please be available at the same state. And if x is equal to 1, so we may move on to the next state. Which is S1. S1 is represented as 0, 0, 1. And now after that, again, depending upon the value of x, if x is equal to 0, we have said that, so it is going to be present, available in the same state. X is equal to 0. If x is equal to 1, it will move on to the next state, which is S2, and S2 is represented as 0, 1, 0. Right. Next is, again, depending upon the input variable x value. If x value is equal to 0, the same state. If x value is equal to 1, please move to the next state, which is S3. Now S3 is represented as 0, 1, 1. And depending upon the x value, once again, if x is equal to 0, it's the same S3 state. If x is equal to 1, S4 state. if x is equal to 1, S4 state. And now again, depending upon the value of x once again, depending upon the value of x once again, if x is equal to 0, get back to the S4 state. If x is equal to 1, if x is equal to 1, please move to the next state, which is S5 state. Can you hear me? Are you hearing me?
Yes, sir.
Right, okay. So after S5, if x is equal to 0, if x is equal to 0, repeat the loop. If x is equal to 1, we are saying that in final state output is equal to 1. So this is my final state. Here my output is equal to 1 whenever x is equal to 1. Whenever x is equal to 1. So output z is equal to 1. Then after that, get back to the starting state. Right. Right now in this, few observations are, and this is nothing but the state, and this is nothing but the binary representation of state. Then what about this? What is x here? External input. Right, this is external input. Now what is z here? What is z? Output or external output, whatever it may be. It's output. Now please tell me generation. So how many clock cycles are required? How many clock cycles are required from this instance to from this instance? ఇక్కడ నుండి ఇక్కడికి ఎన్ని క్లాక్ సైకిల్స్ కావాలి అంటే ఎస్ నాట్ స్టేట్, దెన్ ఆఫ్టర్ దట్ ఎక్స్ ఇస్ ఈక్వల్ టు 0, ఎక్స్ ఇస్ ఈక్వల్ టు 1, అక్కడ వరకు ఎన్ని క్లాక్ సైకిల్స్ కావాలి బిఫోర్ ఎంటరింగ్ ఇన్ టు S1? How many clock cycles are required?
One.
How many clock cycles? Only one clock cycle is sufficient, right? X में depend అవుతుందా? Number of clock cycles X में ఎలా depend అవుతుంది?
0 ఎన్ని క్లాక్ సైకిల్స్ రాదు.
సేమ్ కదా, x0 అయినా కానీ S0 కి వెళ్ళిపోతుంది, x is equal to 1 అయితే S1 కి వెళ్ళిపోతుంది. Now I am saying that how many clock cycles are required for this particular operation అని చెప్పేసి అంటున్నా. See, so SS1 classroom ఉంది and here SS2 classroom ఉంది. SS1 classroom, this is my SS1 classroom and this is my SS2 classroom. Now depending upon the timetable which is framed by the HOD, your class may continue. I will be continuing your class, or I may go and take the class of SS2 class కి వెళ్తాను నేను after 1 hour. Now I am asking, so from here to here what will be the time delay, ఎంత టైం పడుతుందని చెప్పేసి నేను అంటున్నా. Minimum 1 clock cycle, maximum is also 1 clock cycle. Why it will take 2 clock cycles? 2 clock cycles ఎందుకు తీసుకుంటుంది యశ్వంత్?
x0 ఉన్నప్పుడు వెళ్ళకూడదు.
x0 తీసుకున్నప్పుడు it will be going into the same s0, right? So don't confuse here, and simple గా అడిగాను, జనరల్ బేసిక్ థింగ్ అడిగాను. సో ఐఎమ్ నాట్ సేయింగ్ దట్ సో S1 కి ఎప్పుడు వెళ్ళిపోతుంది అనలేదు. ఈ ఆపరేషన్ మొత్తం S0 present state is S0 if x is equal to 0, next state will be S0, else next state will be S1. Now I am asking that what will be the time that is required for this particular operation. Ante one clock cycle. Definitely S1 ki vellali ani cheppesi ledu. Then it depends upon the value of x. Only x is equal to 1 అయినప్పుడు మాత్రమే S1 కి వెళ్తుంది. That is true. But my question is very simple. So x is equal to 0 అయినప్పుడు S0 కి వెళ్ళాలి. X is equal to 1, it should move on to the S1. Now for that particular operation, how many clock cycles are required? That is the question. Right, how many clock cycles are required, Dattatreya?
One, sir.
Right, any doubts on this? No, right? Doubts ఏమైనా ఉందా? అంటే S1 కి డెఫినెట్ గా వెళ్ళాలి అని అనట్లేదు. It may enter into S1 or it may enter into S0 also, anything. Right, how many clock cycles are required for this operation? 1. Right, this is going to happen in my second clock cycle. This is going to happen in my second clock cycle. Now this is going to happen in my third clock cycle. This is going to happen in my third clock cycle. Now this is going to happen in my fourth clock cycle. This is going to happen in my fourth clock cycle. Now I'd like to ask someone. Harita, are you online? Harita, are you online? Harita, are you listening me? Harita, are you online? Rajeshwari, are you online?
Sir.
Rajeshwari, are you online? Okay, right.
Yes.
Then Rajeshwari, answer this question. So in fourth clock cycle, do we get a state S4? Do we get S4 in fourth clock cycle? S4 అనే స్టేట్ వస్తుందా ఫోర్త్ క్లాక్ సైకిల్లో? Hello?
Sir.
No, I can't hear you. Do we get S4 in fourth clock cycle?
X1 ఇస్తే S4 వస్తుంది సార్. S3.
No, right. So Rajeshwari is saying that so whenever I am in S3 state in the fourth clock cycle itself, if x is equal to 1, so the next state will be equal to S4. How many of you accept this, and how many of you will not agree with this particular answer? She is saying that in fourth clock cycle itself, so we'll be getting the next state as S4 if x is equal to 1. How many of you will agree for this? How many of you will agree for this? Positive edge, negative edge, right? So Veerababu is saying that so ikkada this fourth clock cycle it should be a positive edge antunnadu. So if it is a fourth positive edge, then x is equal to 1 unte next state S4 అవుతుంది అంటున్నాడు. Is that correct? Veerababu అందరూ నువ్వు చెప్తుంది?
Yes, sir.
Okay, Veerababu is saying that fourth clock positive edge ఉన్నప్పుడు next state will be equal to S4.
అది after
subjected to
clock
x
is
is equal to 1
x equals to 1 ఇస్తుంది.
Right. Who is answering this? Who answered now?
Sir.
Gautama? Ravin? Who told the last answer? Can you hear me?
Yes, sir.
రైట్. ఎవరు ఆన్సర్ చేసింది లాస్ట్కి, ఆర్ ఎవరు క్వశ్చన్ అడిగింది లాస్ట్కి?
Sir, Gautam, sir.
Gautam, right? Perfect, Gautam. Your answer is correct. We won't get S4 in this fourth clock cycle. Veerababu, you might have confused. We won't get S4 in fourth clock cycle. Fourth clock cycle లో S4 రాదు. Fourth clock cycle లో S4 రాదు. S4 will be generated in fifth clock cycle. Fourth clock cycle లో S4 రాదు. S4 will be generated in fifth clock cycle. See how the clock cycles are being generated here. So if I am drawing this particular clock, if I am drawing the clock here, I'll be marking all the positive edges: first, second, third, fourth, fifth, sixth, and seventh positive edge. So this is first, second, third, fourth, fifth, sixth, and seventh positive edge. Right, so we are not bothered about the initial condition, whatever it is. Now, after the application of the first positive edge, we are saying that it must be S naught unto num. And whenever there is a second positive edge, it will be entering into S1, subjected to the condition that X is equal to 1 here. And S2 will move on to S1 will move on to S2. S2 will move on to S3. S3 will move on to S4. S4 enters into S5, and S5 will move towards S0. X is equal to 1. So when we are getting this particular state, S4 అనేది ఎప్పుడు వస్తుంది? In which state we are getting, sorry, after which clock cycle we are getting S4? Veerababu.
Fourth, sir.
After fourth, after fifth?
Fifth, sir.
After fifth positive edge, we will be getting S4 state. After fifth positive edge, see, only after fifth positive edge వచ్చిన తర్వాత మాత్రమే S4 అనే స్టేట్ వస్తుంది. You cannot generate here itself. ఇక్కడే S3, ఇక్కడే S4, ఇక్కడే S5 generate అవ్వదు. Even though X is equal to 1, we won't get this particular S3, S4, S5 in the same clock cycle. Why? Because we are using edge triggered flip-flops. Whenever there is a next positive edge వచ్చినప్పుడు మాత్రమే S3 అనేది S4 అవుతుంది. Even though you are providing X for all the full clock cycle. ఇక్కడ full clock cycle కి X is equal to 1 ఉందనుకోండి, then also we won't get S4 state. Is it clear, Veerababu?
ఎస్ సార్. అంటే సార్ ఇనిషియల్ స్టేట్ ఎస్ నాట్ అనుకుంటే అప్పుడు ఫస్ట్ క్లాక్ తర్వాత S1 వచ్చింది కదా సార్.
అంటే వీరబాబు, నేను అడిగిన క్వశ్చన్కే కదా నువ్వు ఆన్సర్ చేయాలి. నీ
Yes,
ఆన్సర్
sir.
కి నేను క్వశ్చన్ సెట్ చేసుకోకూడదు కదా.
అవును సార్. అంటే నేను అలా అనుకుంటున్నాను.
Right, okay. So here I have stated that S naught is occurring in the first clock cycle అంటున్నా. In zeroth clock cycle, initial state is S naught. That is not the question. During the first clock cycle, S naught అని చెప్పేసి అన్నా నేను. Then in fourth clock cycle, so this S3 generate అయింది, X అయింది అని చెప్పేసి క్లియర్ గా చెప్పేసాను. You should not get confused, Veerababu. Is it okay now?
ఎస్ సార్.
ఇప్పుడు డౌట్ ఉందా? Right. So then after that, so now what about this? You see here, Z is equal to 1 could generate అయిపోయింది. Now tell me how many clock cycles are required for this particular operation to take place. S5 state X is equal to 0 or X is equal to 1. After that, Z is equal to 1. How many clock cycles are required for this operation? How many clock cycles are required for this operation? How many clock cycles? Number అడగట్లేదు. How many clock cycles are required? 1 clock cycle సరిపోతుందా? Only for this operation. S5 దగ్గర నుంచి next x is equal to 0 or x is equal to 1 depending upon that generation of z value or moving on to the same S5 value. So for this particular operation, how many clock cycles are required? Jyotsna, Dimple, JVS, Bindu, Gautam, Dattatreya, Sharanya. How many clock cycles are required for this operation?
సార్ అది మీలీ మిషన్ సార్ 3 మిషన్ మొత్తం.
This is a Mealy machine. Output is written out of the state. State byte రాస్తున్నా.
1 clock cycle సార్.
Right, 1 clock. Perfect. 1 clock cycle is sufficient. This all takes place in a single clock cycle. So as soon as S5 is as soon as S5 state ఎప్పుడైతే వచ్చిందో, that is 101, and here itself what will happen is, if x is equal to 0, next state will be equal to the same S5 state అయిపోతుంది. And when do we get the same S5 state? In the next clock cycle or the same clock cycle? S5 will be moving on to the same S5 in the next clock cycle only. ఎప్పుడైతే next positive edge వస్తుందో అప్పుడే S5 కి వెళ్ళిపోతుంది. Now suppose if x is equal to 1, what will happen is S5 will move to the S0 again after this positive edge. But generation of output z is equal to 1 is an asynchronous phenomenon. This is asynchronous. This doesn't depends upon the clock. Positive edge గురించి that wait చేయదు. Z is equal to 1 అనేది. Just depending upon the value of 101, it is going to generate z. Depending upon the combinational circuit, a small combinational circuit పెట్టుంటారు. Maybe z is equal to the combination of AND gate. ఇవి రెండు AND gate పెట్టారనుకోండి, suppose 1 into 1 is equal to 1. And for this AND gate, we doesn't require any positive edge or negative edge, and hence in the same clock cycle, the value of z will be generated inside the Mealy machines. We are talking about Mealy machines. So the z value output in the Mealy machines are asynchronous. Outputs in Mealy machine are asynchronous. They are not depending upon the clock value. Right. Is it okay? Is it clear for everyone? Whereas the state diagram is in this way. If it is S0, x is equal to 0, output is 0, S1. Then again, if it is one by 0, S2, 1 by 0, this is S3, 1 by 0 is S4, S5, this is 1 by 1, 0 by 0, right. Now tell me which one is easier to understand, or which one is easier to draw here, either a state diagram or else the algorithm. This is a state diagram and this is an algorithm. ఇది algorithm, ఇదేమో state diagram. more information is conveyed in state diagram or in algorithm?
State diagrams.
State diagram లోనే ఉందా? Now in state diagram clock analysis చేయాలి అంటే clock cycle analysis చేయాలంటే ఎలా చేస్తారు? First clock cycle, second clock cycle, third clock cycle, what is happening in each clock cycle, how you will be analyzing that? We can analyze, but
స్టార్టింగ్ స్టేట్ తెలియట్లేదు.
స్టార్టింగ్ స్టేట్ తెలియట్లేదు. స్టార్టింగ్ స్టేట్ మనం S0 అనుకున్నాం అనుకోండి, సో దట్ ఈస్ నాట్ ఎ ప్రాబ్లం. సో the main problem is, see, okay, right, so for this it is okay. Now suppose for the traffic light controller, if I am supposed to draw a state diagram, if it is a more machine, now how I am supposed to draw it? ఎలా డ్రా చేసాం మనం? S0 అని పెట్టేసి, so there are 12 outputs which are written here. Which is nothing but, so which is complicating the diagram. And also now if you see this algorithm, this algorithm is additionally having the information of this particular clock cycles clear in a clear way. సో ఏ క్లాక్ సైకిల్లో ఏమేమి జరుగుతుంది అని చెప్పేసి ఇన్ఫర్మేషన్ అనేది క్లియర్గా ప్రజెంట్ చేస్తుంది. అఫ్ కోర్స్ ఇన్ ద స్టేట్ డయాగ్రామ్ ఆల్సో that particular information will be present, but to extract that particular information, so we need to spend some time. Meeku state diagrams perfect ga vachundali, and then you need to understand it properly. So S0 appudu 10 eppudu avutundi, when this Z is being generated, idi eppudu generate avutundi, so idi eppudu act chestundi, after the positive edge avutunda or before the positive edge, when it is happening. So those confusions may arise, and all those confusions will not be there in this particular algorithm. And algorithm is straight away. So whatever logically మీరు ఏదైతే అనుకుంటారో అదే ఇక్కడ పెట్టేస్తే అయిపోతుంది. That's it. So nothing else. Right. So we'll do one more problem on this, and we'll discuss what are these things.
సార్ కొన్ని ఎగ్జాంపుల్స్ లో ఎక్స్టర్నల్ ఇన్పుట్స్ అన్ని చోట్ల ఉండట్లేదు కదా సార్, అంటే ఇప్పుడు ఎక్స్ ఉన్నట్టు, అంటే ఒక స్టేట్ లో యూజ్
ఉండాల్సిన
చేస్తాం,
అవసరం లేదు. రైట్, ఎక్కడ?
అంటే ఇంతకు ముందు
This
చేసాం
particular
కదా
Z value ఇదా?
సార్, ఇది కాదు సార్, ఇంతకు ముందు చేసాం కదా సార్ జీసీడీలో స్టార్ట్
External inputs are there, but external inputs are more machine. We have drawn there the more machine, mealy machine or more machine, either draw చేసాం. External outputs రాసాం కదా అక్కడ కూడా, that is a mealy machine which we have drawn, but నేను outputs మొత్తం కూడా కింద రాశాను. ఆ వాల్యూ, A load value, B load value, A select value, B select value, all these are nothing but the outputs itself. ఇవన్నీ outputs ఏ. S0
ఎక్స్టర్నల్ ఇన్పుట్స్ సార్,
to S1
ఎక్స్టర్నల్ ఇన్పుట్స్ మనం అంటే ఇక్కడ కొన్ని వాడాం కదా సార్, అది ఫస్ట్ దాని పేరు గుర్తులేదు సార్, ఒక సిగ్నల్ వాడాం కదా సార్ ఇక్కడ S0 దగ్గర ఉన్నప్పుడు
reset value. Reset value. So I have said that, so the reset value here must be equal to, so whenever reset value is equal to 1, S0 ki vellipotundi, and after that we are supposed to make reset is equal to 0. Reset 0 ni chesesin tarvata meeku ee operation mottham start cheyali ani cheppesi anna. Reset 1 పెట్టేస్తే, so irrespective of other conditions మళ్ళీ S0 కి వెళ్ళిపోతుంది. Once you go through that, and again once again you may ask me, నేను అది డౌట్ క్లారిఫై చేస్తాను. రైట్, సీక్వెన్స్ డిటెక్టర్ 1010 సీక్వెన్స్ డిటెక్టర్ overlap model sequence detector. So for this, the algorithm initially I'll be taking S0 state, then after that whenever the x value is equal to 1, whenever the x value is equal to 1, it moves on to the next state, S1. If x is equal to 0, back to S0. Then after that, from S1, if the x value is equal to 0, we may move on to the next state, S2. Right? If x value is equal to 1, what should happen to the S1 state or S0 state? Sequence detector.
S1, sir.
Right, perfect. So it should move on to the S1. Then after that, from S2, x value if it is 1, what should happen? And if it is 0, what should happen? If it is 0, what should happen?
S2 sir.
S2 లో 0 అయినప్పుడు S2 కి వెళ్ళిపోతుందా? సీక్వెన్స్ డిటెక్షన్
Reset
రీసెట్ అవ్వాలి రైట్. రీసెట్ ఇట్ షుడ్ రీసెట్. If x is equal to 1, then it moves to the next state. 1 0 1 0. We haven't detected the sequence. Right, 1 0 1 is detected. Now here, if x is equal to 1, what will happen? And if x is equal to 0, what will happen? If x is equal to 0, what will happen? 1 0 1 has been detected. If it is 0, what will happen? And 1 0 1, if it is 1, what will happen? 0 అయితే ఏమవుతుంది, 1 అయితే ఏమవుతుంది? This is an overlap model అంటుంది. So if it is 1, it moves on to the state S1. Right. So if it is 1, right. So if it is 1, it moves on to the next state. Right. Then if it is 0, what will happen? It should generate the output value 1. Then after that, it should enter into S2. It will be entering into S2. It will enter into S2, right? So total here we have 4 states. So this is 0 0 0 1. This is 1 0, and this is 1 1. All right. So clear for everyone what we have done here? So we have taken an initial condition as S0 overlap sequence detector for 1 0 1 0 condition. So S0 తీసుకున్నాం, and so whenever x is equal to 0, whenever x is equal to 0, so it will be present in the same loop. If x is equal to 1, next to S1 state. So in S1 state, it says that I have already detected the presence of 1. Then 1 0 1 0 low, I have detected, but this particular one, you please detect the remaining sequence. So that is the information which is conveyed by the state. So S1. Now after S1, if the x is equal to 0, if x is equal to 0, so we are in loop. we are detecting the sequence properly, and hence we can move forward to the next state. So next state S2 కి వెళ్ళిపోతాం. If it is 1 again, దీని తర్వాత నెక్స్ట్ వాల్యూ కూడా 1 వచ్చింది అనుకోండి, దెన్ యూ మే ప్రజెంట్ ఇన్ ద సేమ్ లూప్. మళ్ళీ S0 కి వెళ్ళిపోవాలి. Sorry, S1. We are supposed to move in the same S1. Then after that, after 1 0, next if x is equal to 1, so if x is equal to 1, next we can move on to the next state. If x is equal to 0 here, 100 is not required. We are trying to detect 1010, so 100 will not match with our sequence, and hence a reset condition or go to initial state. So go to initial state. Okay, then after S3, so 101 is detected. So 101 is detected. After that, if it is 0, right, so I have detected my sequence, output will be equal to 1, and since it is an overlap, so 1010, it will be matching with this two. If we are matching these two, the suffix and the prefix values, so 10 is nothing but a state which is detected across S2 కండిషన్, S1 కండిషన్. ఇక్కడ డిటెక్ట్ అయిపోయింది 10 అనేది, రైట్ బిఫోర్, రైట్ ఇన్ S2 కండిషన్ లో 10 అనేది డిటెక్ట్ అయిపోయింది. సో మూవింగ్ అక్రాస్ S2 కనెక్ట్ చేసాం. If it is 1011, so if it is 1, then if we compare this with the original sequence, 1 and 1 are matching, and hence we may move to the state which has detected already 1. ఇక్కడ డిటెక్ట్ అయిపోయింది, in S1 లో డిటెక్ట్ అయింది, so we are supposed to move to S1 with output is equal to 0. So this is it. And this particular operation which is there, so from here to here it takes a single clock cycle. One clock cycle పడుతుంది ఇక్కడి నుంచి ఇక్కడికి. One clock cycle is sufficient. One clock cycle is sufficient. Next, one more problem. ఇది నాకు మళ్ళీ రేపిస్తారా? కావాలంటే ఫొటోస్ తీసుకోండి. ఓవర్ చెప్పేసి ఒకసారి మీరు చూడండి. ఇది కావాలంటే మళ్ళీ నాకు ఇవ్వండి, ఫొటోస్ ఏమైనా తీసుకోండి. Right. So the question is, can you hear me? Right, this is the first, this is second, or third, fourth, fifth, sixth, and seventh. So, right. Generation of waveforms. Generation of waveforms, or the generation of different clock signals from one particular clock input value. Now, can you draw a simple algorithm for this? Simple algorithm for this. See here, if this is state A, state B, state C, state D. So tell me, how many states are required for this particular problem? Any states kaval? Any states kaval? First మీరు time period చూడండి.
Yes,
Or
sir.
else check, right, 4 states is sufficient. So the first, what you are supposed to say is, when your signal is getting repeated, or the maximum time period a signal kundi, adi check cheyali. See this, see the last signal, which is s anedi chudandi. S anedi, see here, during the first clock pulse this is 1, during the second positive edge this is 0, then again it is getting repeated, 0 1 0 1 0 1 0, repeat అయిపోతా ఉంది. So what is the time period of this particular S signal time period enti? If this is my clock, the frequency is, this is f clock anukunte, or else time period of this signal is t. Now please tell me, what is the time period of the signal S?
F clock by 2.
Time period lo in
2t, sir.
terms of time period, right, it will be 2t, right? This is 2t time period, double undi, time period is double. Now what about R signal? R signal,
3 times.
3.
right? So this is 1t, this is another t, this is another, so this is 3t here. Now what about the Q signal?
40.
So this is 4t. What about the P signal? Is it 5t?
40, yes, sir. 40, yes.
So this is also 40. 40 time period. So in each time period, we are getting the output values. Alane assume చేసుకోండి. So here in the first clock pulse, after the first positive edge, this is equal to 1, this is equal to 1, output here is 1, output here is 1. So after the first positive edge, in the first state, output must be equal to 1, right? In my second state, so whenever I'm crossing the first positive edge, so here it should be 0, here it should be 1, here it should be 1, and here it should be 0. Then after the second positive edge, after the third positive edge, this must be 0, this must be 1, this must be 0, and what, this gets repeated. We need not to worry about this repeats. S అనేది ఇంకా రిపీట్ అయిపోతుంది. Then after the fourth positive edge, so this is 0, this is 1. What about this? What about
0,
R
sir.
signal? So this also gets repeated. This also gets repeated. Then after this, after the fifth positive edge, this gets repeated and this gets repeated. Now we are supposed to depend now who, on what factor? So we are supposed to choose this as 0, this as 1, this as 1, and this as 0. A factor mida, which is the controlling signal enti.
X1, X2.
Right, perfect. So x1, x2 are nothing but external inputs. X1, x2 are nothing but the external inputs. Now external inputs, based upon this particular clock signal, we are supposed to generate this particular output signals. Now please draw an algorithm for this. Algorithm draw cheyandi. The state is represented by this particular rectangular box. state representation. Then in this is condition, decision box, then this is output. It is named as a conditional output box. Right, you may use these three elements and draw an algorithm for this particular waveform generation, which will have 4 states: S0, S1, S2, S3. 4 states untai. After 4 states, again repetition. After 4th state, repetition. S4 S3 తర్వాత మళ్ళీ S0 వస్తుంది. Now every one of you draw the state diagram for this. Sorry, algorithm state machine. Two more minutes. Is it done? Anyone who has drawn the diagram? Can you hear me? Hello? Right. ఎవరు డ్రా చేయలేదా? Right. So observe this. So it is equal to 1 here. Now what does this information says in meaning, Andy? Whenever I am present in state S0, my output is
independent of x1 x2.
right, independent of x1 x2 ante kada. Whenever in first clock cycle after first positive edge, my output is equal to 1. My output it is not depending upon x1 x2 values. 0 0 unna 0 1 unna 1 0 unna 1 1, anything it may be, my output is simply 1. So that is represented here. Now in S1, what is happening in S1? S1 లో అలాంటిది ఏమన్నా ఉందా? Can we write here as z is equal to 0 or z is equal to 1 రాయొచ్చా?
No, sir.
No, we cannot write. So it is depending upon the values of x1 x2. Now let us draw those things here clearly. x1, x1 can be 0 or x1 can be 1. x1 can be 0 or x1 can be 1. x1 can be 0 or x1 can be 1. Now whenever x1 is equal to 0, again we have x2 condition. We have x2 condition, this condition. Now tell me what is the output here. Whenever x2 is equal to 0, what is the output? And whenever x2 is equal to 1, what is the output? Whenever x2 is equal to 0, what is the output? Whenever x2 is equal to 0, what is the output in S2?
0.
Sorry, S1 state. 0, right? If x2 is equal to 0, output is equal to 0. And tell me whether I need to move to the next state or to the initial state. ఎక్కడికి వెళ్ళాలి? Next state or initial state? Next state, right? I'm supposed to move to the next state. Let me write this next state as some S2. x2 is equal to 0 అయినప్పుడు ఇది. If x2 is equal to 1, what is happening? If x2 is equal to 1, what is happening? x1 0, x2 0, 1. x1 0, x2 is equal to 1. Now what is the output here after the second clock pulse? ఏమైంది అవుట్పుట్ ఏమైంది? 1 అయిపోయింది. Right. Z is equal to 1. Move to the next
ఇక్కడ ఈ
state.
బ్రాంచ్ లో కూడా జనరేట్ చేయాలి సార్ అవుట్పుట్.
Right, we are supposed to generate this also. ఇక్కడ కూడా generate చేయాలి. Now in x1, after x1 ఎప్పుడైతే 1 అయిపోయిందో ఈ కండిషన్ చూద్దాం. ఇప్పుడు x1 is equal to 1.
0 అయినప్పుడు 0 అని చెప్పు. x2 0 అయినప్పుడు
x2 is equal to 0 అయినప్పుడు
అదే సార్ x1 0 x2 0 అయినప్పుడు z1 ఈక్వల్ టు 0 అని రాయలేదు సార్. z is equal to 0 అని రాయలేదు సార్.
we need not mention that. అది ఏం మెన్షన్ చేయట్లేదు అంటే z is equal to 0 అయినట్టే.
ఓకే సార్. ఓకే.
సో ఇక్కడ ఏం మెన్షన్ చేయట్లేదు అనుకుంటే డిఫాల్ట్ కండిషన్ ఇస్ ఇట్ అజ్యూమ్స్ దట్ z is equal to 0. అక్కడ అవుట్పుట్ అనేది 0 అని చెప్పేసి దాని మీనింగ్ 0/0 అని ఉన్నట్టు. రైట్. సో x1 is written here. Now write down the values of x2 also. Right. Write down the values of x2 also. Right. Now whenever x2 is equal to 0, what is happening? What is the output that is being generated? Em generate avutundi? 1 generate avutundi. Now do we supposed to move to the next state or to the initial state? C కి వెళ్ళాలా స్టేట్, లేదు అంటే ఇనిషియల్ స్టేట్ కి వెళ్ళాలా? Right, we are supposed to move to the next state. So x2, if it is equal to 0, if it is equal to 0, z value is equal to 1. So please move on to the next state. Right, perfect. Now if x2 is equal to 1, what is happening here? x2 is equal to 1 అయినప్పుడు ఏమవుతుంది?
0 sir.
x2 is equal to 1. Output is 0. Now tell me where I need to move, to the initial state or to the next state.
Initial states.
Right, after that the loop is supposed to repeat. Loop అనేది repeat అయిపోవాలి ఇంకా. So we may move to the initial state again. This happens if x2 is equal to 1 and x1 is equal to 1. Is it clear? So whenever x1 is equal to 1, x2 is equal to 1. Now what is happening whenever x2 is equal to 1, x1 is equal to 1? In this particular state, after the second clock pulse, output is equal to 0 and move to the initial state. So loop is going to get repeated. Loop is going to get repeated. See, this is happening in the first clock cycle. S not అనేది ఫస్ట్ క్లాక్ సైకిల్లో అయిపోయింది. This happened in the first clock cycle, and this entire process is taking place in second clock cycle. Will you agree with me or any objections? Second clock cycle లో అవుతుంది ఇది మొత్తం కూడా. Will you agree with this? సరే, x1 ఉంది, x2 ఉంది, దానికి 2 క్లాక్ సైకిల్స్ పడతాయి. అలాంటి ఏమైనా డౌట్స్ ఉన్నాయా? Even though we have 2 control signals, so it is going to take place only in single clock cycle. Single clock cycle is sufficient in that particular state, right? So this is the first clock cycle. Second clock cycle is also done. Now we will be moving on to the third clock cycle. The third clock cycle lo emoutundo chudandi. See, in third clock cycle, do we suppose to generate this particular signal s ni generate cheyala inka? S ni generate cheyala? Do we separate s ni generate cheyalsina avasaram ledhu. It is going to get repeated. So this is not required. This is not required. Signal s need not generate after third clock cycle. It is going to get repeated. It is going to get repeated. So 1-1 condition will not come into the picture. So 0-0, 0-1, 1-0, 1-1. So 1-1 condition will not come into the picture. Right now, what we are left out with, left out conditions enti? What are the left out conditions? 0 0 0 1 1 0. So 0 0 అయినప్పుడు ఏమవుతుంది, 0 1 అయినప్పుడు ఏమవుతుంది, 1 0 అయినప్పుడు ఏమవుతుంది? Now I will take x2 here. నేను x2 తీసుకుంటా ఫస్ట్. I will be taking x2 here first. x2 first. x2 is equal to 1. x2 is equal to 0. Now whenever x2 is equal to 1, do I need to take another conditional box, decision box, x1 box తీసుకోవాల్సిన అవసరం ఉందా?
No, sir.
Why it is not required? Tell me.
1-1 eliminated.
Right, x1 only 0 ఒక కండిషన్ మాత్రమే సరిపోతుంది. ఇంకా ఈ 1-1 కండిషన్ అసలు లేదు. సో ఇట్ ఈస్ నాట్ డిపెండింగ్ అపాన్ x1 వాల్యూ. ఇంకా x1 వాల్యూ మీద డిపెండ్ అవ్వదు. Only output depends upon x2 itself. Here output depends upon x2 itself. So this is a kind of minimizing the algorithm. This is a kind of minimizing the algorithm. Based upon this algorithm, we will be designing the hardware for the circuit. So that is the reason we are minimizing the algorithm here, right? X1 is not required. Inka malli x1 akkada place cheyalsina avasaram ledhu, right? Now tell me what will be the output for that particular condition whenever x2 is equal to 1. What is happening? x2 is equal to 1 అయినప్పుడు output ఏం generate అవుతుంది in the third clock pulse?
1 sir.
1, sir.
1 is getting generated. So I will be placing it as z is equal to 1 under. Now tell me whether I need to move to the next state or to the initial state. Right, I'm supposed to move on to the next state. My next state will be S3. Right, this is done. Now this particular side. Now do I need to take x1 here or can I skip x1 also? ఇక్కడ x1 తీసుకోవాలా అవసరం లేదా? Right, we are supposed to take x1. Why? Because x1 it can be conditions may be 0 0 or condition may be 1 0. So x2 is taken here and x1, there is two possibilities. So that is the reason we are supposed to take x1. Now tell me what is happening here. So 0 0 1 0. For 0 0 condition, what is happening? What is the output in the third clock cycle? 0. If x1 is equal to 0, if x1 is equal to 0, if x1 is equal to 0, it moves on to the next state. Output is equal to 0. If x1 is equal to 1, what will happen? If x1 is equal to 1, what will happen? If x1 is equal to 1, output is equal to 0 only, but to the initial state. But to the initial state. But to the initial state. Right, this is also done. So now now in the next state, that is in S4, in S3, do we know the outputs? S3 lo generate ainaya avaleda? Have we generated the outputs in S3 state? No, we haven't generated. So outputs are not generated. Outputs are not generated in S3. We are supposed to generate in S3. S3 in the sense which clock cycle? S3 in the sense which clock cycle? Right, fourth clock cycle. S0 is first clock cycle. S1 is second clock cycle. S2 is third clock cycle. S3 is fourth clock cycle. Fourth clock cycle outputs are not defined so far. We are supposed to define them. Now eliminate the signals which are already getting repeated. So R signal is eliminated. So P, Q, R, S. So S signal is already eliminated. Now tell me which signal is to be eliminated now. Which signal need not R need not get generated or need not get generated. Why? Because it is moved to the initial state. So loop gets repeated, R automatically generates. Now we are supposed to define the outputs for P and Q signals. Only for P and Q signals ki matram generate cheste saripotundi. P and Q. P and Q. Right. So this is, I'll be taking x1 here. X1, what are the values that are required for x1? Only 0, 1, right? We are supposed to write down the outputs for 0 0 condition and 0 1 condition. Ee rendu conditions ke generate cheyali. So for 1 0 condition it is not required. For 1 1 condition it is not required. Why? Because 1 0 is associated with R and 1 1 is associated with S. These are already getting repeated. Repeated loop lo already generate అయిపోతున్నాయి, and hence we are supposed to generate only the signals for 0 0 and 0 1. Now do we need to take the x1? Is it required? X1 తీసుకోవాల్సిన అవసరం ఉందా? Right, straight away we can do it with x2, right? Straight away we will do it with x2. X2. Right, x2. If it is 0, what is the output? And if it is 1, what is the output? If it is 0, what is the output? If x2 is equal to 0, what is the output? 0. If x2 is equal to 1, what is the output?
0.
So this is not 1 kada, it's 0 kada, right? So if it is x2 is equal to 0 ఉన్నప్పుడు, so x2 is equal to 0, output is 0. If x2 is equal to 1, output is equal to 1. So do I need to write down the value of x2? x2 అనేది రాయాలి అక్కడ, అవసరమా?
No, sir. Directly output.
Directly.
Do we need to write down the x2? x2 is not required, right? It is not required. I'll be saying that after s3 we may move on to the initial state. Will it work?
Directly.
Is it clear why we haven't taken the values of x1, x2? ఎందుకు తీసుకోలేదో? It is not required, independent of x1, x2 values. So the output is equal to 0 only. So from s3 state, straight away we have drawn a loop towards the s0. So this is nothing but the algorithm for generation of this particular 4 waveforms. So the clockwise we can say the outputs. The first clock లో ఏం జరుగుతుంది, సెకండ్ క్లాక్ లో ఏం జరుగుతుంది, థర్డ్ క్లాక్ ఏవి
అవుట్పుట్ సిగ్నల్ ఎక్కడ తీసుకోవాలి?
అవుట్పుట్ సిగ్నల్స్ ఇవే జనరేట్ అవుతున్నాయి కదా. z is equal to, it depends upon the values of ఆ ఇన్పుట్స్ x1, x2 మీరు ఏవైతే ఇస్తారో దాన్ని బేస్ చేసుకొని మీకు అవుట్పుట్ వేవ్ ఫామ్ జనరేట్ అవుతుంది. అంటే మీకు ఇక్కడ 4 అవుట్పుట్ వేవ్ ఫామ్ జనరేట్ అవుతున్నాయి. ఇప్పుడు 0 0 ఇవ్వగానే మీకు అవుట్పుట్ అనేది ఇది కనిపించేస్తుంది. మీకు అవుట్పుట్ వేవ్ ఫామ్ కనిపిస్తుంది కదా దీనికి. ఆ అవుట్పుట్ వేవ్ ఫామ్ అనేది మీరు 0 0 అనేది ఇచ్చేస్తే x1, x2 అనేది, then you will be getting this particular answer. ఇవి మొత్తం ఈ స్టేట్ డయాగ్రామ్స్ మొత్తం కూడా డిఫైన్ చేసేసి, సో x1, x2 0 0 ఇస్తే మీకు p అనేది వేవ్ ఫామ్ వస్తుంది. 0 1 ఇస్తే q వస్తుంది, 1 0 ఇస్తే r, 1 1 వస్తే s వస్తుంది.
ఎట్ టైం సింగిల్ అవుట్పుట్ వస్తుంది.
ఎనీ టైం ఓన్లీ సింగిల్ అవుట్పుటే వస్తుంది.
ఇందాక బ్లాక్ లో 4 అవుట్పుట్.
రైట్ రైట్, ఓకే, ఓన్లీ వన్ అవుట్పుట్ మాత్రమే వస్తుంది. Right. So here how many clock cycles we are using? Maximum number of clock cycles any use just 4 clock cycles are required here. So first clock cycle, this is the first clock cycle, this is second clock cycle, third clock cycle and fourth clock cycle. 4 clock cycles. So 4 clock cycles. So for p and q generation it requires 4 clock cycles. For r it requires 3 clock cycles. For s it requires only 2 clock cycles. So this is what. Now serial adder. Algorithm for serial adder. Can you draw it? Can you draw it? Algorithm for serial adder. Ci minus 1, Ai, Bi, Ci and Si. Tell me how many states are present here in a serial adder? How many states? Any states ఉన్నాయి serial adder లో? Hello, can you hear me? Right. How many states are present in serial adder?
Two states.
Serial ladder, we have already drawn the mealy machine, more machine. I want to draw you some serial ladder key. There are only two states. Now this is one particular state, and this is another state. Right, state is not initial state. Now here, if it is AB values, depending upon AB values, now tell me what will happen here. Whenever AI is equal to 0, BI is equal to 0, state is S naught. What will be the next state and next output? AI is equal to 0, BI is equal to 0, and S naught state. What will be the next state and next output?
S naught and 0.
So the next state is the same S naught. Output is equal to 0. Next state is equal to same S naught. Output is equal to 0. This is what we are dealing with. Now if it is 1, what will happen? 1 అయితే ఏమవుతుంది? Output gets generated here. Z is equal to 1 or Si is equal to 1 in this particular loop. Si is equal to 1. Okay. Now in this, whenever AI is equal to 1, అప్పుడు ఏమవుతుంది? If it is 0, what will happen? If it is 0, what will happen? Si is equal to 1, and we will be directed to the same state. And if it is 0, what will happen? Sorry, if it is 1, what will happen? If it is 1, it moves on to the next state. S1. Output is 0. Output is 0. Right now we are present in S1 state. Now again the values of AI and BI. Again it is A is equal to 0, A is equal to 1. The values of B. Right, tell me. So if 0 and 0, what will be the value next state and what will be the output here?
S naught and 1.
S naught and 1. S naught and 1. Si is equal to 1, and we are supposed to move to the S naught state. Right. So we are dealing with this particular condition. Right. If it is 1, what will happen? 1 అయితే. Let us make a small change here. If it is 1, what will happen? Same ante? S1 state, right. Okay. Now this particular condition. So whenever it is 0, what will happen? Right, if it is 0, right. If it is 1, what will happen? Right. Si is equal to 1 and my output. Right. This is what? This is for serial adder. Once you go through this, then you will be understanding whether the state diagrams are easy or algorithm state machines are easy. So ఏది ఈజీయో మీకు అర్థమవుతుంది. Can you see my screen? Is my screen visible?
Yes.
Right, we will be finishing the class in the next few minutes. The features of the algorithmic state machines are this. So it describes a sequence of events as well as the timing relationship between the states of a sequential controller and the events that occur while going from one state to the next state, which you have already seen. So this you have already seen. Now ASM chart contains one or more interconnected ASM blocks. Now what are this particular interconnected ASM blocks? So each ASM block consists of one state box, decision box, and conditional output box. State box, decision blocks, and a conditional output box. So this is a state box, this is a state box, this is a conditional decision box, this is a state box, this is a decision box, and this is a conditional output box. And this particular complete package is called as an ASM block. One ASM block అంటాం దీన్ని. సో ఈ వన్ ASM బ్లాక్ అనేది వన్ క్లాక్ సైకిల్ తీసుకుంటుంది. అండ్ ఫ్యూ ASM బ్లాక్స్ మే హ్యావ్ కండిషనల్ బ్లాక్స్, ఉండవచ్చు ఉండకపోవచ్చు, అండ్ దేర్ మే బి డెసిషన్ బాక్సెస్ ఆర్ దేర్ మే నాట్ బి డెసిషన్ బాక్సెస్ ఆల్సో. But this state box is compulsory. So each ASM block contains exactly one state box together with the decision boxes and conditional output boxes associated with that states. Right. So every ASM block in an ASM chart specifies the operations that are to be performed during the common clock cycle. So an ASM block, ఒక ASM block has exactly one entrance path ఉంటుంది, exit paths మాత్రం multiple ఉంటాయి. See this, you will understand here. So here we have a single entrance, and ఇక్కడ నుంచి exits అని ఉన్నాయి. So this is one exit, this is another exit, so this is another exit, this is another exit. We have 4 exits ఉన్నాయి. Sir, ఇది కదా సార్ exit అని చెప్పేసి అనకండి. This is not the exit, this is the exit of state box. If we are saying ASM block exits ante, these are the ASM block exits. ఇవి ASM block exits అవుతాయి. Each ASM block అంటున్నాడు. An ASM block has exactly one entrance path and multiple exit paths. A path through an ASM block from entrance to exit referred to as a link path. You need not remember that this particular terminology. Link path ante enti adi anavasaram. So the operations specified within the state and the conditional outputs in the boxes are performed in the data path subsystem lo avutayi. Internal feedback within the ASM block is not permitted. So within the ASM block you cannot interconnect. It means you cannot connect from here. So if you are drawing a line you cannot draw a line from here to here. ఇలా డ్రా చేయలేరు. సో నెక్స్ట్ క్లాక్ సైకిల్లో ఏమవుతుందని చెప్పేసి డ్రా చేయాలి కాబట్టి యూ కెనాట్ డ్రా ద పర్టికులర్ లైన్స్. Each block in the ASM chart describes the state of the system during one clock pulse interval. Each block in the ASM chart describes the state of the system during one clock pulse interval. When a digital system enters the state associated with a given ASM block, the outputs indicated so and so, so and so. So you can read it. That's it. So this is regarding the ASM blocks. So why ASM blocks, why ASM charts is described for you when it is not present in the syllabus? Right, on the whole, the conclusion as per the textbook is, compared to the state diagrams, ASM charts are very much useful whenever we are entering into the complex designs. For complex designs, for large designs, for complex designs, ASM charts are beneficial. Why? Because ASM charts are easy to understand, easy to analyze, easy to draw, and also this will give the relationship with respect to the timing, clock timing ni batti information kuda istayi. And comparatively state diagrams kanna ASM chart anedi easy. So this is textbook conclusions. Now why I have taken this particular ASM charts is, the reason is, so the most of the further designs or higher designs like CPU kaochu, or else the design of a division circuit, or a multiplication circuit, or the circuit which is used to find out arithmetic mean, or a circuit which is used to find out the Fibonacci sequence, or a sorting circuit, or any other processor. All these are explained with the help of ASM charts only. If you see the textbooks, the most of the textbooks are using ASM charts to represent a division algorithm, multiplication algorithm, arithmetic sorting programs, processor, CPU, ఇవన్నీ కూడా ASM charts ని బేస్ చేసుకొని ఎక్స్ప్లెయిన్ చేశారు. So if you cannot understand ASM charts, then obviously you cannot understand what is the diagram that is given for the division and multiplication. So that is the reason I have taken up this particular topic, ASM charts. So now try to refer this particular today's notes, and you may follow any textbook, standard textbook for ASM charts. So once you draw few designs, then you will be understanding it easily. Tomorrow we'll do few more problems on ASM charts, and also we'll try to complete the part which is pending regarding the traffic light controller. Is it clear? Right. Now it is as simple as that. So why you are learning English? టెక్స్ట్ బుక్స్ అన్ని ఇంగ్లీష్లో ఉన్నాయి కాబట్టి నేను ఇంగ్లీష్ నేర్చుకుంటున్నాను. ఇంగ్లీష్ వస్తే నా టెక్స్ట్ బుక్లో ఉన్నది అర్థమవుతుంది. సో వై యు ఆర్ లెర్నింగ్ ASM చార్ట్స్? టు అండర్స్టాండ్ ద ఆర్కిటెక్చర్ విచ్ ఇస్ డ్రాన్ ఫర్ CPU డివిజన్ మల్టిప్లికేషన్. ఏదైతే ఆర్కిటెక్చర్ డ్రా చేశారో ASM చార్ట్స్లో అది అర్థం చేసుకొని, ఇఫ్ పాసిబుల్ ఐ కెన్ డూ మినిమైజేషన్స్ ఆర్ ఆప్టిమైజేషన్స్ ఇన్ దట్ పర్టికులర్ డిజైన్. సో దట్ ఈస్ ఓన్లీ ద రీజన్. అంతకుమించి ఇంకో రీజన్ లేదు. And the other reasons are, it is easy to draw, easy to understand. So direct representation, timing representations, ivanni clear ga untayi. All those things are there. So but the main reason is to understand the complex designs. ASM charts are required. Right. So I'll be winding up the session here. So if you have any doubts, you may ask me the latter, or you may text me also. Whenever I am having free time, I will be seeing it and I'll be giving replies for your questions. Thank you.